Assalamualaikum to all panels, Dr. Jeffrey, Dr. Sabrina and Dr. Shariza. First of all, I would like to introduce myself. My name is Nur Sabrina Sahira binti Sheikh Omar with the matrix number B051710062. I am assigned under Prof. IR Dr. Muhammad Ashadi Azam bin Muhammad Abid throughout my final year project. I am going to present about my topic, which is tailoring the grain size of metal ammonium lead iodide perovskite thin film with the functionalized reduced graphene oxides in order to enhance its morphological and optical properties. Before I start, I would like to share a quick story about how solar cells work. A solar cell is a device that converts the visible light into electricity via a photovoltaic effect. Perovskite solar cells, material with a crystal structure of ABX cube, is the third generation of solar cells that emerging photovoltaic, classified including dye-synthesized and organic. Because of the cubic lattice nested octahedral layered structure and the unusual optical, thermal, and electromagnetic properties, perovskite materials have drawn an attention. As we can see from the graph shown, perovskite solar cells show drastic improvement in the energy conversion efficiency less than a decade, from 8.5% in 2009 to 23.3% in 2020 by National Renewable Energy Laboratory. This remarkable progress making perovskite solar cells the best potential candidate for the new generation of solar cell in the future. While the advantages and the remarkable that make perovskite solar cells to be the star rising among all the solar cells, sadly, perovskite solar cells do have many pitfalls in order to meet the high performance and high stability. Long-term device stability is the core problem encountered by the perovskite solar cells, mainly due to the poor morphological of perovskite material, which causes trap of the charge that may lead to the deteriorations of its critical characteristic. These causes that usually happen on the morphological sections are ion migrations at grain boundaries, small grain size, decrease in the light harvesting, and lastly, it leads to the short-term stability of the perovskite solar cells. Meanwhile, the common causes of the optical degradations because of conversions to the wide bandgap, surface trap, current voltage leakage, and finally, drop the optical absorptions of the perovskite solar cells. My objectives in this project, number 1, is to prepare the sulfonated functionalized of reduced graphene oxide in the perovskite thin film. Number 2 is to optimize the morphology of the metal ammonium lead iodide perovskite film with a different ratio of functionalized reduced graphene oxide integrated in the perovskite solution. Number 3 is to investigate the effect in optical properties of the perovskite material with different surface morphology. Meanwhile, my scope in this project, number 1, is the surface functionalizations through the treatment of sulfuric acid to the pristine reduced graphene oxide under reflux condition by using the sulfonation process. Number 2 is observe effect of different weight ratio of functionalized reduced graphene oxide into the perovskite solution to the perovskite thin film morphology. Last one is to analyze the optical properties of perovskite thin film after integrated with different Ratio of functionalized reduced graphene oxide. On the literature review section, as we can see, is the result from the SEM image grain of the grain. Figure 1. The perovskite film with the SGO indicates the better crystallinity and orientation compared to the control. Meanwhile, the figure shows that the perovskite solar cells were perfectly modified with both RGOG-P3H3. I can conclude here, the additions of the graphene-based materials do helps in enlargement of the grain size in the metal ammonium lead iodide. Same source of the previous slide, figure 1 result obtained from the UV visible spectra shows the stronger diffraction intensity further verifies higher crystallinity and larger grain size of the perovskite films with SGO. Meanwhile, this result corresponds to the stronger absorptions in the UV visible spectra by the SGO compared to the control. Figure 2, also from the same source from the previous slide, UV visible absorption spectra shows the result of the perovskite solar cells were perfectly modified with both RGOG-P3H3 and CNTG-P3H3 agent because of the largest absorbent. So I can conclude that the addition of the reduced graphene materials into the perovskite solar cells do helps in enhance its optical properties as well as morphological properties. Preparation of the sulfonated RGO. First, 75 mg of the prepared GO was added in a water 75 ml. After silication for 2 hours, brown dispersion of graphene oxide was formed. Then, 5% weight of sodium carbonate was added into the dispersion to adjust the pH value to 9 or 10 in between. To prepare the reduced graphene oxide, 600 mg sodium borohydrate in deionized water 50 ml was added into the solution, and the mixture was then heated to 80 degrees Celsius and kept for 1 hour. After centrifuging and rising with water for several times, the reduced graphene oxide was dispersed in deionized water 75 ml under ultrasonic treatment. Then the aryl diazonium salt used for sulfonations was initially prepared from the reaction of 4-aminobenzenes sulfonic acid 46 mg and the sodium nitrate 80 mg in deionized water 10 ml and concentrated HCl solutions 1.2 ml in the ice bath. Then the solution was added to the reduced graphene oxide suspension under M2. After 4 hours reaction, the sulfonated reduced graphene oxide was centrifuged and washed with deionized water for several times and dried at 60 degrees Celsius under vacuum. Moving to the methodology section, firstly is the synthesis of the RGO via top-down method from graphite powder using ascorbic acid as a reducing agent. Secondly, the synthesis of the functionalized reduced graphene oxide via sulfonation process using sulfuric acid under reflux condition. Next, prepare 5 different ratio of functionalized reduced graphene oxide in the perovskite solution and fabricate the functionalized reduced graphene oxide doped perovskite thin film. Lastly, sample testing and evaluation on the morphological and optical properties. Characterization method, I'm going to use 3 types of characterizations method in my project. First is scanning electron microscopy, SEM, to examine the morphology changes of the perovskite thin film after integration with the functionalized reduced graphene oxide. Second, UV visible spectrometry. We use UV visible spectroscopy to measure the absorption ability of the perovskite thin film. Lastly, X-ray diffraction analysis, XRD. We use XRD to determine the atomic and molecular structure of a perovskite and functionalized reduced graphene oxide. For this project 1, for week 2 and week 3, I have covered on the understanding in the morphological and optical properties of the perovskite. Meanwhile, for week 4 and week 5, is on the understanding on the reduced graphene oxide synthesis method and the properties. Week 6 and week 7 is on the understanding the functionalized reduced graphene oxide method, and the following 3 weeks from week 7 to week 10 is on understanding on the expected results on the morphological properties, while the following 3 weeks starting from week 11 to week 13 is on the understanding of the expected results of the optical properties. Method applied in this understanding process is through journal papers and research paper reading. Work planning for the following PSM2 next semester is by synthesis of the reduced graphene oxide from graphite powder by using the top-down method for 1 month starting from March, followed by synthesis of functionalized reduced graphene oxide via sulfonating process using sulfuric acid on the next month. Also for 1 month, same goes to the preparations of the functionalized reduced graphene oxide doped perovskite solution, fabrication functionalized reduced graphene oxide doped perovskite thin film for next 2 months of a period starting from May until June, while lastly is the sample testing and evaluation of the morphological and optical properties and analysis starting from April until June. At the end of the day, the result that will be expected from this project is the enlargement in the metal ammonium iodide perovskite grain size and the increase of the optical absorption ability. So before I end my presentation, in a nutshell, I can conclude that the main intention of the project that I will do for the next semester is to understanding the effect of the integrating the functionalized reduced graphene oxides in the perovskite thin film, how its affect the grain size in order to enhance the optical and morphological properties in order to achieve the better stability of the perovskite solar cells.